Hello everyone, good evening. My name is Puneet Kansal. I'm mentor at Geeks4Geeks. So we will discuss about today we will discuss about in this session we will discuss about time complexity analysis. Okay. So we will cover this topic in its entirety. We will finish this topic. We will attempt lots of questions related from this topic, and you people will be able to solve the questions, all the questions related to this topic. So I have seen many questions related to uh, they give us some code, and they ask us, okay, what is the time complexity of this particular code. Okay, so we will start from very basics, and we will go up to the gate level, and we will be able to finish this topic today within 2 hours. Okay. Okay, before moving on, please write in the chat box if my screen is visible to you and I'm properly audible to you people. Okay, please write in the chat if I'm properly audible to you or not. Okay, so meanwhile you write in the chat if I'm audible or not. Let me give you a 2-minute description about the gate crash course which is going on. This session is the part of the gate crash course. Uh, so this complete gate crash course is actually, let me tell you, in this complete gate crash course we are covering the five most important topics from every subject. Okay, five most important topics from every subject. So I have to say even five most important, most expected topics for gate 2023. Five most important expected topics for gate 2023 we are covering from every subject in this complete gate crash course. Okay, and this is our first topic in algorithm course which we'll cover in this session particularly. So this complete gate crash course is going to helpful for two type of students. One is who who say that, sir, we have not prepared very much and we are not sure that we will be able to clear the gate exam or not. So if you are going through this complete gate crash course which is free of cost, you can find out the detail in the description. So if you register for this course, this is completely free course, complete free course. If you will take this complete course, then I'm giving you surety that you will be able to clear the gate exam, at least clear the gate exam. Okay, why? Because in every subject here we are covering the five most expected topic which from where the question can come. Okay, and we are covering this topic in its entirety. We are completely finishing these five topics. So there is very high chance that the questions will come from these topics only. Okay, so if you are not sure, then hello Digit, nice to see you back. So let me know if I am properly audible or not. Okay. Okay. So first, those students who are appearing, who are not confident that okay they will be able to clear the gate exam or not, they will be able to clear the gate exam. One thing is that after taking this complete gate crash course which is free of cost. Okay, and second thing is, if you are already prepared so much and you are confident about clearing gate exam, but you are focusing on the good rank, then this course can help you to revise the most important topics from every subject. Five most important topics from every subject you can revise with the help of this gate crash course. Okay. Okay, so I hope my voice is complete clearly audible to you people. Please let me know if my voice is audible or not, so that I can start this session on time complexity analysis. In this we actually go through various codes. We will try to find out the complexity of different type of codes. Okay, I have taken the category of every type of category I have taken actually. Okay, so all type of category I have taken that can be possible actually. Okay, so we will cover all of them. Okay, thank you for replying, Divyanshu. Nice to see you back. Veer, nice to see you back. And Gate Aspirant 2023. Can this course help to learn from scratch? Yes, definitely. Gate Aspirant 2023 is asking, is this course can help to learn from scratch? Yes, Actually, we are covering 5 most important topics from every subject. Okay, this is the first topic I'm covering, and prerequisite for every topic is none. Nothing is required. I will teach you right now. I will start from basic and we will go to the advanced up to the gate level here itself. Okay, so you can start from scratch itself, means you can just come and attend the lecture and you can go. That's it. Okay, okay, okay. Thank you, Divanshu, for replying. So let's start. So let's start with this session. Let's discuss time complexity analysis. So we will cover, okay, again the same thing. We will cover the introduction, means I'm going to start from basics of the time complexity. We will see various growth functions, time complexity growth functions. We will see various examples. These examples are set by me, and after that again the same, you people will solve the gate questions. Okay, you people will solve the gate question. I will also help you people here. Okay, so start from basics, then some examples, and then gate question. That's it. Okay, so okay, so first of all, very basics, what is time complexity? So time complexity is time taken by a algorithm while compilation plus while runtime. Total time taken while compilation and runtime is the time complexity of an algorithm. Okay, but we do not consider this time, but we do not consider the compile time, because compile time is a constant time. Actually, compile time is a constant time. This is the constant time. Okay, this is the fixed amount of time that is taken by the algorithm. Okay, so actually compile time, I can say where one important line here. Compile time, if you compile us, you compile every software, only one time in its life. You compile every software only one time in its life. Once that software is ready, then only at the end you execute one time. Okay, while making the software, you can check out, you can do diagnosis so many times, but once the software is ready, then you convert the high level language into low level language and provide the exe file. Okay, so you execute the, if somebody asks you how many times you compile a software in, how many times we compile a software in its lifetime. So one time we compile, and we can run many times. We can run even that software, even keep running all together for many years. Okay, but the compilation is done only one time. Okay, so this is the constant amount of time taken by an algorithm. So actually time complexity of an algorithm is the time taken while running, time taken while execution. Okay, so this is the same line written here, because compilation is done only one time in software life. So compile time is constant. Okay, so that's why we do not consider it. We consider only runtime in the time complexity. Okay, so let's talk about now various types of complexity functions. So these are various type of complexity functions: constant, logarithmic, linear, quadratic, cubic, polynomial, exponential. Okay, so these are the different type of complexity functions. Can you people tell me out of these complexity functions, functions, which will take the maximum time? Constant, this one, which one will take the maximum time? So I just want to connect with you people. I want to know how much you know. Accordingly, again, we will move on. According to that pace, we will move on. So please let me know which will take the maximum time, which function will take the maximum time to execute out of these. And please write in the chat which function will take the maximum time. Which function? Please write in the chat. Exponential will take the maximum time. Exponential, this will take the maximum time. Not this one, 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 not this one. Okay, and which one will take the minimum time? Constant. If I say that my algorithm time is order of 1, if I say that my algorithm time is order of 1, then this is the actually minimum time an algorithm is taking. Its mean is that my algorithm is taking constant amount of time. My algorithm is taking constant amount of time to execute. Okay. And if I'm saying that, okay, if I'm saying that, okay, my algorithm is taking order of c power n, okay, and where n is the variable, c can be constant, so this is actually exponential time. This thing is very big as compared to this function. This function is very big as compared to this function. Okay. Okay. uh, okay, so even I can tell you one story also, if you want me, why uh, how this function is taking more time and how this function is taking less time. Okay, so the story is like that actually. Once actually a company, a product based company, I have to say, visit a college campus, and he selected two students from the college for final round, and one student was from mechanical and another student was from CS. Okay, they both were friends actually. He selected these two students for final round of interview, and the company was product based company that was giving 6-digit package actually. So that was, the package was very high. And when they go for the interview, then the interviewer asked one question to them. They asked them to write a program for Fibonacci number, to generate Fibonacci sequence. Okay, Fibonacci sequence. So they both were very happy, mechanical student and CS student. Actually, they both were very happy that, okay, this is the very easy program, and they both write the code. This mechanical student write algorithm 1, and this CS student write algorithm 2. Okay, they both write different code. Okay, to solve this problem actually. And they submitted their code to the company, and company personnel actually check out the algorithm 1 and algorithm 2, and both code were working very fine. Okay, so both were very happy that, okay, the code is working fine. Mechanical student was also very happy that, okay, my code is working fine. But this company actually need only one person to hire. They need only one person. They were having only one position. Then they check out that, okay, they check out that algorithm 1 is taking order of n time. Order of, if I'm saying order of means approximate, you can say. Okay, you can simply replace this order of with approximate keyword. Okay, approximately n time. Okay, so algorithm 1 was taking order of n time, means approximately n time. And algorithm 2, okay, sorry, so algorithm 1 was taking 2 power n time, and algorithm 2 was taking order of n time. Okay, so algorithm 1 was taking 2 power n time, that is exponential. C value is 2 here, so 2 power n time. And algorithm 2 was taking order of n time. Okay, this was taking 2 power n, this was taking n time. Then he check out that, okay, which algorithm is taking more time. Then what he do is that he simply put some value here. Okay, for algorithm 1 and algorithm 2, he put some value. He first give n input as 1. Then he check out that, okay, algorithm 1 is taking how much time? N value is 1, so that will take 2 power 1 time. Okay, and algorithm 2, how much time that will take? That will take 1 time. Let's suppose I'm writing a unit also. Otherwise we don't write the unit while finding the complexity. Just for understanding, I'm writing seconds. Okay, so this is taking 2 seconds, this is taking 1 second. He says that, okay, both are taking approximately same time, asymptotically both are same. So he put some another value. He put, okay, he put 10 here, so this was taking 2 power 10 seconds, this was taking 10 seconds. Okay, so again he put another value, he put n value. So let me write here, he put n value as 1000. And algorithm 1 was taking now 2 power 1000 seconds. Okay, and algorithm 2 was taking how much time? 1000 seconds. How I am getting this? Simple. I put 2 power 1000 here. Algorithm 1 is taking, if n value is 1000, this is taking 2 power 1000 time, and this is taking n time, means 1000 seconds. Okay. Then when the company person see that see this thing, he decided, okay, to whom he have to hire. He immediately decided actually to whom he have to hire. Okay. Do you know? Okay, can you people tell me how much time is this 2 power 1000 second? Any approximation from your side? Can you people tell me? I will come to your all questions. So first of all, you people tell me how much is 2 power 1000 seconds? How much time is that? Any guess? How much time is that? So algorithm 1 is taking this much time to execute. Who is right by this mechanical boy? And CS boy write the algorithm 2, who is taking 1000 seconds. Okay. So can you tell me how much time this will take? How much is this 2 power 1000? Can you tell me? Veer is laughing. Can you tell me how much time this will take? 2 power 1000. 2 power 1000 second is actually 1000 times 2. So how much is that? How much time is that? If I say 2 power 1000 second, actually 1 hour will pass away. This algorithm 1 will not stop. 1 day will pass away. Algorithm 1 will not stop. 1 week will pass away. Algorithm 1 will not stop. 1 month will pass away. Algorithm 1 will not stop. 1 year will pass away. Algorithm 1 will not stop. This mechanical boy got married. He got married, but the algorithm is executing. Algorithm 1 is executing. His kids is asking him, Papa, what type of algorithm you have made? This is not stopping. Even the earth will dissolve in the sun, but this algorithm will not stop. This much time this will take. This much time this will take. 2 power 1000. This much time is this. So this is what I want to tell you is that this is the difference of the logic. This is the difference of the logic. Although both algorithm were working very fine. Algorithm 1 was working very fine. Algorithm 2 was working very fine. Both algorithms were working very fine. But this algorithm is taking this much time. If the user want to generate 1000 Fibonacci numbers, he need to wait for many life. He need to wait for many life actually. Okay, this much time this algorithm is taking. So this is the difference of the logic actually. Okay, and this logic actually you develop in this subject, algorithm. Okay, you develop the which you learn in this subject in algorithm, which is the best approach to solve a problem. This should be the best approach. Best approach means which take less time. That is the best approach. Okay, and here so these are the function actually which are telling us. These are telling us the complexity of different algorithms. Okay, so we can represent the complexity by using these complexity functions. And you have already tell me that, sir, exponential complexity function is having the highest time complexity, and constant have the lowest time complexity. And so this will move like this only. So this have more than this order. Linear take order of n is greater than log n is greater than constant, and this quadratic is greater than order of n, and cubic is greater than n cube is greater than n square, and n power k is a constant. Let's suppose k is 10, so n power 10 is greater than n power 3, and let's suppose c is a constant here. 2 power n is greater than 2 power, let's suppose 2 power n is greater than this. So if a function is having 2 power n time, that will take more time than a function which is taking n power 10 time. So this will take more time than a function which is taking n power 3. So this is will take more time than this will take more time than this will take more time than log n, and this will take more time than order of 1, which is a constant time. Constant time means fixed time. Fixed time. Constant time is fixed time. Okay, so you already tell me this thing. Okay. Okay, so I hope this is clear now. Where the log n will go, log n will lie between order of n and constant. Okay, that will lying here. This is how I have written according to their level of complexity, you can say. Okay, this function, this is the biggest function, exponential. Okay, and this is the lowest function. Okay. Okay. Okay, so let's move on. Now it's your turn. We will increase the complexity level by level, and we will cover all these complexity functions once again. Okay, all these complexity functions we will relate to the actual codes now. So now what you people need to do is, you need to tell me, you need to move with me. I will not explain everything from my side. I will explain, but I will take answer from you. You need to try it. Okay, then only learning will happen. If you will not try, then learning will not happen. Okay, so please tell me what is the time complexity here. If you don't know, please if you don't know, please write -1, so that I can know, okay, how many people know this thing. Okay, so accordingly we need to move on. So please, if you know the complexity, please write the complexity. If you don't know, please write -1. Please write -1 if you don't know the complexity of this. Okay, if you don't know. And if you know, please write it. If you know, please write it. So both way, I will be able to connect with you people. Actually, I will be able to connect with you people, and you can improve yourself also. So you can improve yourself. If you think that if you have given the wrong answer, you can improve yourself. If you don't know, please write -1. If you don't know anything, please write -1. Thanks. Thank you, Gate Aspirant 2023. Okay. So here, see, you can note 2-3 points. Let me tell you 2-3 points. These points will applicable at every algorithm. These points will applicable at every algorithm whenever you are finding the time complexity of any algorithm. Any algorithm. Okay, I'm making some statements now. I'm making some statements. First statement I'm making. Let me write also. Finding the time complexity of an algorithm is finding the time complexity of an algorithm is actually finding that part. Let me write here that part of the algorithm which takes maximum time. So this is very important statement actually. So if somebody asks you what is the time complexity of this algorithm, that code, you simply, what you need to do is, you need to find, if somebody asks you to find the time complexity of an algorithm, then actually you will try to find that part of the algorithm, which take maximum time to execute, So can you people tell me, in any code, don't look at this code only, in any code, I have written a big code actually. Okay, I have write a big code, maybe 1,000 of line of code. Okay, So can you people tell me which part of the code will take the maximum time to execute? Which part of that code which will take maximum time to execute? Which part of the code will take maximum time to execute? Which part? So can I say this thing? The loop inside the codes take the maximum time of a program to execute. I executed a program, and that program is executing instruction by instruction, but according to this definition is saying that if you want to find out the time complexity of any algorithm, simply find out that part of the algorithm, which is taking maximum time, See, this part of the algorithm is taking maximum time, so I can say that finding the time complexity, this is the second point you can note, you can note directly. Okay, finding the time complexity means finding the loop inside the program, if you can find the loop inside the program, you can find the time complexity of that program. Okay, so I find out this loop, I simply will say that, okay, how much time this loop is taking, that is the time complexity of this program. Okay, how much time this loop is taking to execute. So how many times this loop is executing? You can see this loop is starting from 0 going up to 9, that is less than 10 going up to 9. So this loop is executing 10 times. Okay, this loop is executing 10 times. So simply what you need, so this loop is executing 10 times. So I can say that this algorithm is taking how much time? Order of 10 time. 10 is what? 10 is constant. So I will say this will take order of 1 time. Because 10 is constant. Okay. So the complexity of this code is order of 1. So we will take lots of example. Everything will be clear to you. Don't worry. So now I'm making little bit changes here. Please keep replying. Okay, I'm replacing this 10 with 1000. Can you people tell me what is the time complexity of this algorithm now? What is the time complexity of this algorithm? I replace the 10 with 1000. What is the time complexity? Please keep writing. Same. Garima says same. That is order of 1. We'll say order of 1000. And this is order of 1000. And order of 1000 is nothing. Just order of 1. That is again constant. This is constant. Okay. Now I'm replacing 1000 with this number. I don't know. I don't have space. Let me put more 0. I don't know. I want to fill this complete board actually with zeros. So can you people tell me what is the time complexity of this algorithm now? I have put thousands of zeros actually. I have put thousands of zero in front of 1. So how much time this algorithm will take? This still will take order of 1 time. I will say this will take constant time. Although this is taking lots of time, but that is fixed. This time is fixed. This time is not changing. According to the user input. According to the user input. So because this time is constant, although this is a long time, but this is a constant, so we will put this, the time complexity of this algorithm will be in this category. We say that this algorithm belongs to this category. This algorithm is having constant time. I don't know how much time I'm taking, but that is fixed. So this algorithm is taking still constant time. Okay, still that is taking constant time. Order of 1 means algorithm is taking constant time, fixed amount of time. Okay, fixed amount of time. Okay, so if any doubt you can ask me. I'm moving to another question now. Please let me know what is the time complexity of this algorithm. Please keep trying. We have lots of examples with us. Slowly everything will be clear to you. And if you already know these small things, I know these can be easy for you people, many of you, but you will find the content for you also. Okay, if you are already good at these basics, don't worry, I have content for you also. But I will move level by level, so that in the question then you will not say that I don't know this thing. You will be knowing everything, and then you can solve all the gate questions. Please write in the chat box, please write in the chat box, either you know or you don't know. So what is the time complexity of this algorithm? Everyone, please write, please write. If you know, please write. If you don't know, please write -1. If you don't know, please write -1. Okay, if you don't know, please write -1. If you know, write order of whatever is the complexity. Okay, please write the complexity. So Divyanshu say order of n, gate aspirant say order of n, and Digit say linear, Veer say linear, that is order of n actually. So yes, you people are right, this is taking order of n time. Again, finding the time complexity means finding that part of the program which is taking maximum time. Actually I'm finding the loop, so this is the loop. Okay, and how much time this loop will execute, that depend upon the n, that will depend upon the n. This loop will execute n time. How much time this loop will execute actually? This loop, initially I value starting from 1, initially I value starting from 1. Every time I'm incrementing with 20, every time I'm incrementing I value with 20. So initially I value will be 1, then that will be 20, then that will be 40, and so on, that will move on. Okay, so actually this loop will take how much time? N by 20 time. This will take n by 20 time, and this 20 is constant, this 20 is constant. So this will take approximately, I say order of means approximately n time. Exactly, this is taking this much amount of time. Even this is taking more time, like constant time this to execute this statement, constant time to execute this statement, constant time to execute this statement, constant time to execute this statement, and constant time to execute this statement. But to execute this loop, this was taking n by 20 time, n by 20 time. So in n by 20, 20 is constant, so I remove the constant, and these are also constant, I can remove these also. So the total time taken is order of n, total time taken is order of n. Okay, so if I replace this 20 with 2, this that will be little easier for you people. If I replace this 20 with 2, so again, how much time this loop will take to execute, how much time this loop will take to execute? If I replace 20 with 2, every time I incrementing I with 2, every time I, okay, let me increment with 1 only. I write I equal to I plus 1. Every time I'm incrementing with 1. So this loop will execute n time. If I'm saying in place of this statement, I'm writing different statement I'm writing. If I'm writing I equal to I plus 1, I'm incrementing like this. Then this loop will take how much time? This loop will take how much time? N time. N time this loop will execute. Every time you are incrementing I value 1, that will be 1, then 2, then 3, then 4, and go up to n. But if I'm putting I equal to I plus 2, okay, so this time I'm incrementing, I with 2. Every time I'm incrementing with 2, so that will be 1, then 3, then 5, incrementing with 2 every time, 9, 11, so on up to n. How much time this loop will execute? How much time this loop will execute? N by 2 times, n by 2 times. I'm saying, okay, I'm incrementing I equal to I plus 3. How much time this loop will execute? N by 3 times. Okay, so I'm saying, okay, I'm incrementing I value with 20. I'm incrementing I value with 20. So this will be n by 20 times this loop will execute, n by 20 times. Here was 3, here was 3, here was 2, here was 2, here was 1, here was 1, here is 20, here is 20. So these 2, these 3, these 20 is all constant. So we remove the constant and we say approximately this take the constant time. Approximately this take the constant time. Okay, so this program is taking how much time? This program is taking, that is taking constant time to execute. Order of n time, sorry. This is taking order of n time to execute. How that is coming? This loop is taking actually, this loop will execute n by 20 times. Okay, and 20 is constant, we remove. These statements will also execute one time only. So this will take constant time. We can remove these also. We can remove the constants. We can remove the constants. Okay. So now one interview based question now. One interview based question that may be asked in your company also. And if you will go for any IIT, they can also ask. They can ask you, why are removing the constants? Why you are removing the constants? This statement is also taking some time to execute. You are saying this statement is taking constant time to execute, but still this is taking some time, some constant time. Why are removing the constants? This statement is taking n by 20 times, and you are saying that this is taking order of n time. Why are removing the 20? Why are removing the constants? Why we are removing the constant? Any answer from your side? So Ratul says that we care about bigger powers. We care about bigger powers. We are removing constants here. Why we are removing constant? Actually, the answer to this question is that you can note down this statement also. I'm not writing here. Otherwise, that is very important statement. Whenever we find the time complexity or space complexity, whenever we find the complexity of an algorithm, we find the complexity of any algorithm for very large value, for very large input, for very large input. How much large input? N tends to infinity. N tends to infinity. If somebody asks me what is the time complexity of this algorithm, I will try to put n value first 1, then 2, then 3, up to infinity. And then only I will try to find out, okay, how much time this code is taking. So whenever we find the time complexity of any algorithm, we find the time complexity for large input. How much large? N tends to infinity. N tends to infinity. If n is going to infinity, then this 20 is not going to make any difference. The constant factors is not going to make any difference. As this number will grow, actually, as this number will grow up to infinity, we ignore these constant factors. We ignore these constant factors. This is one answer to this question. Okay. What can be the another answer? The another answer is that let's suppose this is you and this is your friend. Okay, you have written a program like this which is taking n plus 1 time to execute. Okay, and your friend actually written a program which is taking n time. Okay, maybe you are taking n plus 10 time. You are taking this much time, your program is taking this much time, and your friend program is taking this much time. And company want to hire a person out of you or of your friend. To whom he have to hire? To whom he have to hire? Actually, the company cannot decide. The company cannot decide. The company cannot decide that, okay, I will hire this person because you are taking 10 unit of time more as compared to this. No, this difference can also be due to the hardware changes. That this difference can also be due to hardware changes. Maybe you are working from i3 processor. Maybe you are working on i3 processor and your friend is working from i7 processor. Your friend is working on i7 processor. Due to this hardware changes, your algorithm is taking little bit more time, constant more time that is taking, but your friend is taking little less time because they are using better hardware. Actually, they are using better hardware. Just because your friend is having i7 processor, the company cannot hire your friend. Okay, so here that's why company will put both of the algorithm in same category. That will say both are same, both belong to order of n category. That will remove this constant. So this is the another reason why the constant factors are removed. So these are interview based questions. Why we remove the constant factors? Okay, why we remove the constant factors? Okay, so the complexity of this code is order of n. If you have any doubt, you can ask me. Otherwise, we are moving to next code. Please let me know what is the time complexity of this algorithm. Please let me know. Please write in the chat what is the time complexity. Everyone, please try it. We will cover all type of complexity functions, and then we will cover all type of gate and ISRO based question from this information what we are getting. Okay, so initially I don't want to leave any point, and after that you will be able to solve all the question. That's it. So please write in the chat box what is the time taken by this algorithm. Chris says order of n. Tripathi say n square. Is that n square? Digit says order of 1. Digit, you are right. Actually, this will take constant time. This algorithm will take constant time to execute. Okay, why this is taking constant time? See, n value is 10 here. N value we are not taking from the user here. N value we are not taking from the user. And how much n value is 10? So this loop will execute how many times? Up to 10 times. 10 times this loop will execute. This is also 10. This is also 10. So these two loops will execute 10 into 10, 100 times. So I will say this statement will execute how many times? 100 times this statement will execute. So total time taken is, okay, this part will take constant time. So I say 1 plus this much time, 10 plus 100. So again, this is constant. This is constant. 1, 1, 1, 1. This much time. So this is how much? Order of 1, 1, 1. This is constant. This is again constant. This will belong to constant class. This will belong to constant class. So this algorithm is taking constant time to execute. They will actually what they are, this is a gate question. Actually what they are trying to do is they are checking that, okay, you are careful or not, you are little careful about the input or not. Okay, they have fixed the n value here, they have fixed the n value here. So n value here is 10, n value is n 10. Okay, let's suppose we are taking this, we are not fixing this n value, we are scanning this n from the user, we are scanning this n from the user. Yes, then the time complexity of this algorithm will be how much? Order of n square. How we are getting order of n square? This is taking constant time, this part is taking constant time, plus this loop will take order of n time, because we are taking input from the user now. We are taking input from the user. That is not fixed. N value is not fixed. Earlier the n value was fixed. So now this loop will execute order of n time, plus this loop will execute, loop will execute n time, inner loop will execute n time, total will execute n into n square time. Okay, so n square. So what we are doing, we are removing the constant factors. We know why we remove the constant factor. We also remove the lower order terms. This is known as lower order term. We remove this also, so the time complexity is order of n square. Why we remove the lower order term? Because we are finding the time complexity for large input. We are finding the time complexity of every algorithm for large input. How much large? N tends to infinity. If n will tends to infinity, then this will impact more. This will not impact that much. This lower order term will not impact, as n will tends to infinity. This is going to impact more. And you know that finding the time complexity, you already know one statement. Finding the time complexity of an algorithm means finding that part of the algorithm which is taking maximum time, so this part is take the maximum time as compared to this part and this part. So time complexity of this algorithm will be this, because this is taking the maximum time. You can see here also, in this part or this part or this part, which is taking maximum time, this part is taking maximum time. So this part will decide the time complexity of the complete algorithm. Okay, so any doubt in this, you can ask. The time complexity for, let me erase it. If n value is 10, then the time complexity will be constant. But if we are taking n from the user, if we are scanning n, if we are scanning n from the user, then the time complexity will be order of n square. Any doubt you can ask, you can write in the chat if any doubt. Otherwise I'm moving to the next problem. Please let me know what is the time complexity of this algorithm. Please let me know. We will cover all type of complexity functions. Actually, we will cover all type of complexity functions. Please try it, keep trying. We will finish this topic. Okay, if any question will come in exam, you will be able to solve. This is my guarantee. Okay, this is my guarantee, because we are not going to leave anything here. But the important part is, please keep replying. Wrong or right doesn't matter. Wrong or right doesn't matter in this class. In the class, that doesn't matter. That will matter in exam. Please type whatever answer is coming in your mind. Please type that. Wrong or right doesn't matter at all. We don't know to each other also. Who is going to blame us right now if we are giving the wrong answer? Please try it. After that, we have lots of gate questions. So you people will be able to solve the gate question only when, if you are trying these questions yourself. Answer doesn't matter, that can be wrong or right, because if you will try, then one thing is sure, when I will explain, then you will understand. If you are trying, if you're not trying, then you may find difficulty. So we get many answers, and Ravish, you are right. Actually, this algorithm will take order of log n time. This will take log n time to execute. This will take log n time to execute. How this is taking log n time? See, okay, we will go a little slow. Okay, so we need to find out how many times this loop is executing. That's it. We need to find out how many times this loop is executing. Okay, so this loop is starting from I value 1 and going up to n minus 1, you can say. Okay, and every time, see, this condition is deciding how many times this loop will execute. This condition is deciding. So every time we are doubling the I value, we are multiplying I with 2. Every time we are multiplying I with 2 here. Okay, so let's try to find out. I value in the starting is 1. Okay, and our loop executed. We print this statement, we print the I value. Okay, again, so initially the I value was 1, this condition satisfied, we come inside the loop, and then we check the condition. We set this condition, we increment, we perform this increment decrement operation, whatever is that. So we are multiplying I value with 2. So then the I value will be how much? I value will be 2 into 1. That will be 2. 2 into I, that will be 2. Again, we will go inside and we will print, and again we will come back and multiply I with 2 again. So earlier in previous turn, I value was 2. Now I value will be 2 into 2, that is 4. Okay, that is 4. We executed the loop. Again we will multiply I value with 2, that will be 8. That will be 8. Okay, again we will execute. So we will keep doing this thing. We will keep doing this thing until I will reach to n. I will reach to n. We will keep executing this loop until unless I will reach to n actually. Okay, so how many times we have executed loop? See here, initially the I value was 1. Okay, and then I can write it like this also. I value was 2 power 0. Here the I value was 2 power 1. Here the I value was 2 power 2. Here the I value was 8. 8 is 2 power 3. Here the I value will be 2 power 4. Every time we are multiplying with 2. If you will multiply 2 power 3 with 2, you will get 2 power 4. If you will multiply 2 power 4 with 2, you will get 2 power 5, and so on until unless we don't get I value n. So we need to reach up to some value. Let's write 2 power k. Okay, we need to reach up to, we are going 0, 1, 2, 3, 4 up to some k, so that we reach up to n, we reach up to n. So this value, this value, this value, I will say this value will should reach to n. Okay, let me write here. So 2 power some k should reach up to n. What is this k? What is this k? This k is telling me, okay, here this k is telling me how many times this loop is executing. So here we can say that, okay, how many times this loop is executing. Here I say, okay, this loop is executed 3 times, 2 times, 1 time. This is telling me this 4 times this loop is executed, and I can say that, okay, k time this loop is executed, k time this loop is executed. And this is what we need to find out. What we need to find out, how many times this loop is executing. Okay, so every time I'm multiplying, I value with 2. So initially that was, that you can say that was 1, then 2, then that will become 4, then 8, then 16, then 32, then 64. Every time multiplying with 2. So we will, at the end we will get some this value which will be equal to n, and we will come out of the loop. We will come out of the loop. So, and this k is telling us how many times we are executing the loop, how many times this loop is executing. So we need to solve this thing, and let's solve this thing. Let's take log both side. Let's take log both side. Log of 2 power k and is equal to log of n, and this is the log formula. Log of a power b is equal to b into log a. So this is one log formula. If something is in power, that will come in the front. Okay, b come in the front, that's it. Okay, so his k is in the power, so k will come in the front. This will be log 2 equal to log n. Let's take base 2. Let's take log base 2 both side actually. Okay, let's take log base 2. Okay, now what is the value of this log 2? If we have base 2, the value of this is 1. The value of this is 1. Log of base 2 is 1. So what is the k value? K value is log base 2 n. And what is k? K is telling us number of times loop is executing. Loop is executing. Okay, so now we find out how many times this loop is executing. This loop is executing log n time. So what is the time complexity of this loop, this code? That is order of log n. That is order of log n, actually log n base 2. Log n base 2. I hope this is clear to you. This was little mathematics here. This is not faster. Yes, this is faster growing than order of n. This loop is growing faster actually, and this loop is growing, but this algorithm, I say, will take less time as compared to order of n. So log n is smaller function. If somebody asks you which algorithm will take more time, the algorithm which is taking log n time or which is taking n time. So this algorithm is taking less time because we are reaching to n in faster way. So if any doubt, you can ask. Otherwise, simply one thing you can remember: if we are multiplying with 2, every time multiplying with 2, every time doubling the value, then the time complexity of that algorithm will be log n. Okay, let me make it easy for you people. Let me make these all complexity function very easy for you. Okay, all of them very easy. Let's take a real life example. Okay, so let's suppose I have n stairs. And I'm standing at the bottom of the stair. I want to go at the top. I have n stairs. Step by step, if I will go, I have n stairs, n steps I need to take to reach to the top. So I'm standing at the bottom. Okay, you people tell me. Let me erase this board. You people tell me. Let's suppose I'm standing at the first stair and I want to go at nth stair, and I'm taking one step at a time. I'm taking one step at a time. I'm taking one step at a time. Taking one step, 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 one step. In how many steps I will reach to the top? Can you people tell me? I'm standing at the lowermost uh, stair. First step I'm standing. I want to go to the nth step. I'm taking one step only at a time. In how many steps I will reach to the top? In how many steps? So if that I will reach in how many steps? In n steps. In n steps, I will reach to the top. In n step, I will reach to the top. Okay. So here the time complexity will be order of n because I'm taking n steps to execute. Okay. You people tell me. Now I'm taking two steps. I'm skipping one stair. I'm skipping one stair. Every time I'm skipping, I'm just playing like a child. I'm skipping one stair. I'm jumping. One stair I'm skipping. In how many steps I will reach to the nth stair? In how many steps I will reach to the nth stair? Please keep mentioning in the chat box. In how many steps I will reach to the top? If I'm every time I'm taking two steps means jumping two stairs means you can say okay I'm skipping one stair. You can think like that also. Can you tell me? N by 2, that will be n by 2. So this will take n by 2 me half steps. That definitely I'm skipping one step. Every time I'm skipping one step, definitely that I will take half steps to reach to the top. But this is again asymptotically. Asymptotically means approximately we remove the constant n time I'm taking. Okay. If somebody asks me, I'm taking 20 step at a time. I'm taking 20 step. I am standing at the top bottom most, taking 20 step at a time. Again 20, again 20, again 20. I want to reach to the end. Okay, I want to reach to the end. So in how many steps I will reach? I'm taking 20 steps. I'm moving like a Superman. I'm taking 20 steps at a time. Then in how many steps I will reach to the top? So I will reach to the top in n by 20. N by 20 steps I will take. I will take n by 20 steps to reach to the top. Again, the time complexity is n, constant here. Okay. Okay. So now you people tell me another thing. I'm standing at the top. I'm standing at the top stair. Okay. I want to come to the bottom. I want to come to the bottom. Okay. I'm standing at the top. At nth stair I'm standing. Okay. Now, what I'm doing, I'm decrementing one at a time. I'm taking one step down at a time. One step, one step, one step, one step. In how many steps I will reach to the bottom? I will reach in n steps. I will reach in n steps. So if I'm taking two steps from the top going downside, how many steps I will reach to the bottom? N by 2 steps. Half steps I will take. Every time I'm skipping one stair, skipping one stair. Okay, so two at a time I'm taking two steps. Two steps I'm skipping. Okay, like that. So if I values I minus 20, in how many steps I will reach from top to the bottom? N by 20 steps. This much steps I will take. Otherwise, all are actually order of n only because 2 and 20 are constant here. Okay, so these are the actually loop which are going from 1 to n. This is the loop which is going from n to 1. So this is that complexity of how we are getting n. Okay, now again the I value is 1 and I want to reach to the n, but this time I'm multiplying I value with 2 every time. Initially that was 1, then that become 2, then 4, then 8, then 16, then 32. So then 64 like that. Okay, and let's suppose n value is 64 only. N value is 64 only. In how many steps you reach to the 64? So if you will take the log of 64, if you will take the log of 64 base 2, what is the log of 64 base 2? So log of 64 base 2 is you need to make the power of 2. What should be the power of 2 to make it 64? That should be 6. So log of 64 is actually 6. Log of 64 with base 2 is 6. Okay. So how many steps I'm taking here is, so to reach to the 64, 1, 2, 3, 4, 5, 6 step I'm taking to reach to the 64. 6 step I'm taking. Okay, 6 step I'm taking to reach to the approximately, you can say, okay, approximately 6 step I'm taking to reach to the 64. So if every time I'm doubling 4, 8, 16, 32, 64. So somebody asks you what is the time complexity, you can say log of this value, and this is n, log of n. So that will, this algorithm is taking log n time. This algorithm is taking log n. Why? Because every time this is doubling. Okay. Okay, I hope this will be clear to you people. Now let's suppose, now I'm changing little bit here. Let's suppose I'm, rather than this statement, I'm writing I equal to 3 into I. 3 into I. I'm changing I equal to 2 into I, replacing this with this. I equal to 3 into I. Let me write here for more clarity. 3 into I. I replace this statement with, actually earlier there was 2 into I. Okay, you know this thing. Earlier that was this. Now I replace it with this. So what will be the time complexity of this algorithm now? Anyone can tell me? Anyone? So if any doubt, you can also ask. Okay, please ask me the doubt. Otherwise, I right now, see, I cannot see your faces, and you need to ask the doubt. If you have any doubt, you need to ask. Okay. So Veer says that, and actually Digit also say that that is log n base 3. That's it. Now this time you are, what you are doing, 1, 3, 9, 27. So what you are doing is every time you are multiplying with 3, 3, 3, 3, 3. Here you were multiplying with 2, 2, 2, 2, 2. Every time you were doubling. Now you are tripling every time. Okay. So the complexity of this algorithm will be how much? If I am using this statement, order of log n, same log n, but base 3. But base 3. Okay, base 3. So if somebody say 30 is here, 30 into I, every time I'm multiplying with 30, so base 30. Okay, simple, base 30. Okay, so let's move to the next example now. Can you people tell me what is the time complexity of this algorithm? Please look at it. We are taking examples. After covering all, I'm trying to cover all type of complexities actually. Once we will be able to cover all complexity, and you will be able to understand, okay, what type of code give what type of complexity, then that will be easy for you to find out the complexity of different algorithms. Okay, that will be easy for you people. See, base is base is not a constant factor. Okay, that is attached to this function. This is, you cannot say this is constant. Okay, this is attached to a function. Okay, so if I say the complexity of your algorithm is order of 2 power n, and you start saying that, sir, 2 is constant, I want to remove the constant, so why the complexity will be order of n? No, we cannot remove this 2. This 2 is related, is fixed with this function now. Okay, so this is not constant now. Uh, this is not constant. But if I'm writing 2 power n into 2, I can remove this 2. I cannot remove this 2. Okay, similarly we cannot remove this 2. So this is different thing, and this is not equal to this. Okay, both are different. This will grow more faster. This will grow more faster because every time you're multiplying with 3, 3, 3, 3. So this loop will come out more early as compared to this. So this will take less time. This will take more time if you're comparing both of them. So what is the time complexity? So I think gate aspirant already shared this. Again, this is taking order of log n time. See, here you are standing at the topmost stair. You want to come at the bottommost. Every time you're dividing the value now. Earlier, what you were doing, you were multiplying. You were multiplying with 2. you were multiplying with 2, you were doing like 1 2 4 8 16 32 64, you were doing like that. Okay, let's suppose rather than 20 I'm writing 2. Let's make it little easy. So I by 2, if I'm writing I by 2, so I'm standing at 64, so I will say 64, then 32, 64 divided by 2 is 32, 32 divided by 2 is 16, 8 4 2. So in how many steps, if I'm standing here, I will reach to the 1. This is asking this thing. If let's suppose 2 is here, let's suppose 2 is here. Here you are saying I will take log n time. Okay, then here also you will take how much time? You are coming from top to bottom now. Every time you are dividing with 2, every time you are dividing, here you were multiplying with 2, here you are dividing with 2. So this will also take order of log n time, log n base 2, order of log n base 2. Okay, okay, let me erase this thing. And earlier 20 was here. Can you tell me what should be the answer here? What should be the answer? If 20 is here, if I'm dividing with 20, you were multiplying with 20, then you says that log n base 20. Here also you are dividing with 20, so we will say again log n base 20. See, either you are standing at the topmost stair, you are starting from the topmost, from the n, you are coming down with the same pace. This is same as you are going from 1 to n, but you are multiplying with, you are multiplying I value with I into 20. If you are going 1 to n, so this is the same thing. Here you are standing at the top, you are coming from the top, you are dividing with every time with 20. The same pace you are coming down. So this loop will execute the same way as this loop will execute, which is going from 1 to n, every time multiplying with 20. It's same like you are taking one step and going up, that is taking n steps, and you are standing at the top, you're taking doing minus 1 by 1 1 1 1 1, again that will take n step, again that will take n step. So this is also taking order of log n base 20. This is also taking order of log base 20. Okay, let's move on. What about this? How much time this algorithm is taking? Yes, digit. If you need to mention, if you can mention is explicitly that okay, that is base 2 or base 3 or base 4, if they have mentioned this thing. Okay, sometimes they do not mention the base. It's okay if this is, sometimes they don't mention the base in question. They may be comparing only they are functionally, they may be comparing n, log n and all that. So what is the time complexity of this function? Can you tell me how many times? See this loop, look at this. This is the outer loop, this is inner loop. So whenever you find the complexity, you multiply how many times this is executing with how many times this is executing. That's it. So how many times this loop, outer loop is executing? See, here we are incrementing one by one. In outer loop, we are incrementing one by one. We are starting from 1, we are going to n and taking one step at a time. So how many times this loop will execute? Outer loop n time. Outer loop will execute order of n time. N time outer loop will execute. And how many times inner loop will execute? You know this thing, how many times inner loop will execute. See, we are starting from 1 going to n. Every time we are multiplying with 2. Every time we are multiplying I value with 2. So how many times this loop will execute? Internal loop. Order of log n. Even I say log n base 2 because you are multiplying with 2. Log n base 2. You know that if every time you multiply with something, that will become in the form of base. If and the complexity is in log n, and you need to just multiply them. The complexity of this. So how many times if I can say how many times this statement will execute, that will execute n into log n time, and more specifically base 2. Asymptotically, approximately. Why I'm saying approximately asymptotically? Because I'm not counting these constant factors. Whenever I say asymptotically or approximately, that's mean I'm not telling exact time complexity. I am removing the lower order terms and constant factors. If you are using this symbol, okay. So the time complexity is n log n. So the question again, the same question I left earlier. The difference between big O and theta. What is the difference between big O and theta? Big O and theta. Actually, big O tells us the upper bound. In the second lecture of algorithm, we will cover the asymptotic notations. Okay, and we will cover lots of gate questions also from asymptotic notations. There we will cover all these asymptotic notations. Okay, right now I'm giving you just brief idea. Big O notations tell us about the upper bound, maximum time taken by an algorithm. This tells us maximum time taken by an algorithm. Okay, if somebody says that, if one student come to me and he say that, sir, my algorithm is taking this much time, big O of n square time, what I will understand, what he is saying that, sir, you give any input to my algorithm, any type of input you give, that will not take more than this time. Upper bound of my algorithm is n square, that will maximum take n square time. You give any type of input, you give any type of input, that will take maximum this amount of time. If we will talk about theta notation actually tell us about, if actually there is one more notation, that is omega. Okay, so omega tell us about the lower bound. Lower bound means minimum time taken by an algorithm. Minimum time taken by an algorithm. If somebody says that, sir, my algorithm 2 is taking omega of n square time, he is telling me that his algorithm will not take less than n square time. He will definitely take n square time. Minimum this much time he will take, definitely. This algorithm, minimum. Okay. And this is telling about the maximum time, how much this algorithm is taking. See, this algorithm is not, this thing is not telling me, big O is not telling me about the lower bound, how much minimum time this algorithm is taking, I don't know. How much maximum time this algorithm is taking, I don't know. What I know, if we are using big O notation, maximum time taken by an algorithm. If you're using omega notation, minimum time taken by an algorithm. This is the information they are providing me. Okay, and theta means if upper bound is equal to lower bound, if both are same for an algorithm, if both are same, then I can represent it with theta. If somebody says that my algorithm is taking order of n square time, then what I will understand, he is saying me that, sir, maximum time taken by my algorithm is n square, and minimum time is also n square. He is telling me this thing. He is saying that, sir, upper bound and lower bound of my algorithm is same. What is that? N square. You give any input, my algorithm will minimum will take this much amount of time, and maximum will also take this much amount of time. If these both are same, then rather than using these two notations, we use one notation. So this is the brief idea. We will discuss this thing in very, very detail with lots of gate questions in the next algorithm lecture next week. Okay, so that will come in the next week. Let's move to the next question now. Please try this question. How much time this algorithm will take? Please write in the chat box. See, let me tell you one thing. Although still I'm moving, I'm not moving very fast, I'm not moving very slow. Okay, trying to make the balance. I'm not moving very slow also, I'm telling you. So if you will take the Geeks for Geeks course, actually, if you will go through the Geeks for Geeks course, then that course, the complete gate course actually, In that course, we are discussing every point in very detail. Okay, we are going uh, every point in very detail. Okay, we are going very slow, and you can speed up over there. You can watch like that. But here I'm trying to make moderate mode actually, so that the student who already know so many things, they also keep getting information, and the student who don't know anything, they will remain connected. Okay. Okay, so please write the complexity of this program. So how many times this loop is executing? So here we have two increments actually. Here am I incrementing the I value with 2. Okay, and here I'm okay, I'm doing one modification here. I'm multiplying here. I'm putting multiply rather than divide. I'm multiplying it. Okay, rather than divide, I'm multiplying it. So I equal to I into 2. I equal to I into 2, and we get the answer from one answer from Tripathi. He says that the answer is log n, and he is right actually. Okay, see here I am multiplying I value with 2, and here I am incrementing I value with 2. Okay, see I value in the starting was 1, then that want to reach up to n. What I'm doing is I'm incrementing I value with 2 here, and here I'm multiplying the I value with 2. Actually, this statement will make more impact on how many times this loop will execute as compared to this addition statement. It's just like it's just like the same as if somebody asks me, okay, you please, we start from 1 rupees, and I give him two more rupees. Every time I'm giving two more rupees, and one another person is multiplying his money with 2. He is doubling his money. He is doubling his money. Then definitely he will say that addition of 2 rupees is not making any difference. What is making difference? Every time who is doubling my money, that is making difference. So the how many times this loop will execute will depend upon this second statement more. Okay, so I can say asymptotically this will take log n time. Asymptotically I say approximately. This will make impact, no doubt. This statement is making impact, but very little. Because we find the complexity for n tends to infinity. So this statement will make very less impact, plus 2, and this multiply will always doubling the I value. So I value will reach to the n. So this second statement will, the role of second statement will be more. Okay, ये जो statement है ना, ये ज्यादा impact कर रही है इस वाली statement से. ये वाली statement ज्यादा impact कर रही है. Okay, so that's why this is log n. Okay, what is the time complexity of this algorithm? Anyone? So I think this, and after that one more example we have. That's it, and we will move to the questions then. So this two more slides are left, and after that we will move to the GATE and ISRO questions. And believe me, maximum question you will be able to solve yourself. And if you will think carefully, you will be solve all the questions actually. Here itself, I'm not taking question from my side. I have taken examples from my side to cover different topics actually, to cover different type of complexities. After that, simply you can attempt any question actually. What is the time complexity of this one? Okay, digit you are asking from the previous slide, that is log n base 2. That is log n base 2. Answer is log n base 2. Okay, if in option somebody will give you log n, or actually usually you in GATE exam they will not provide the base here. They will give you options like this. Okay, then then you need to choose, okay, which is the time complex. So previous one is this. Okay, even though they don't provide the base. Okay, that's why I'm also not writing the base. Otherwise you are right, this is more correct, this is more correct if we are mentioning the base. Okay, so what is the time complexity of this one? Exponential, yes. This is not exponential, sorry, this is not exponential, this is not exponential. No, this is not exponential. This is not n log n. Mad Max, this is not n log n. This is not 2 power n. Divyanshu, this is not 2 power n. This is not exponential. So I value is initially is 2, then I value will be I power 2. This is what? This is same as I equal to I power 2. Okay. So next time the I value will be 2 power 2. I power 2. Here the I value is 2. So this will be 2 power 2. Next time the I value will be how much? 2 power. This is the I value we have. Again we will make the power of 2. Again we will make the power of 2. See, we will keep doing like that. I'm writing here we have space. Next the I value will be, see, this value we have right now, and we will make the power of this value with 2. See, let me write here 2 power 2. This statement I'm writing first. Again power 2. Okay, this is what we are doing. Okay, so this thing actually, this thing we can write in some other way also. We can write in some other way also. That will make easy for us to understand. Actually, we will make a series here. Actually, in that case, you will able to understand. Okay, how many times this loop is executing then. So we have this thing. I'm writing here 2 power 2, then power 2, then power. This is how our loop is. This I value is changing. Okay, so one thing is clear. We are moving very fast to the n. हम n के पास बहुत फास्ट जा रहे हैं. एवरी टाइम हम उसके पावर में 2 डाल दे रहे हैं. i की वैल्यू 1 से स्टार्ट हो रही है, 2 से स्टार्ट हो रही है और n तक जा रही है. वो बहुत फास्ट जा रही है क्योंकि जितनी भी वैल्यू हमें हर बार मिल रही है उसको हम मल्टीप्लाई कर देते हैं. i इंटू आई कर दे रहे हैं. इसका मतलब क्या हो गया? आई स्क्वायर का मतलब क्या हो गया? i इंटू आई. ओके, तो हम बहुत फास्ट n के पास जा रहे हैं. तो एक्सपोनेंशियल तो हो ही नहीं सकती है. ये तो हम बहुत फास्ट जा रहे हैं. नंबर ऑफ टाइम दिस लूप विल एग्जीक्यूट दैट विल बी वेरी लेस. ओके, तो ये कुछ ऐसे आई की वैल्यू चेंज हो रही है हमारी. ये वैल्यू मैं उठा के यहाँ पे ले आया. इसको हम ऐसा लिख सकते हैं ना, इनको हम मल्टीप्लाई कर सकते हैं आपस में 2 इंटू 2 इंटू 2. सो दैट इज 2 पावर 8. और इस 2 पावर 8 को मैं ऐसा लिख सकता हूँ. इस 8 को मैं ऐसा लिख सकता हूँ 2 power 3. So this 8 is actually 2 power 3. 2 power 3 is 8. Okay. 2 power 3 is 8. So here I can replace this with 2 power 3. Okay. So I replace this thing with 2 power 3. What will be the next value of I? If you will again put the square, actually the next value of I will be, you can check out 2 power 4. You can check out that will be 2 power 4. What will be the next value of I? That will be I equal to 2 power 5. Okay, you can check out, and so on. We will go up to 2 power some k. I don't know what is the value of k, but up to some k we will keep doing this thing. Okay, and when up to some k, after we will reach here, actually we will reach where? We will reach to this value should be equal to n. This value should be equal to n, and when this value will be equal to n, we will come out of the loop. We'll come out of the loop. So what we need to do, we need to find out this value of k. What is this k? Again, this k is telling us how many times this loop is executing. See, this k is telling us this is 2 power 1, 2 power 2 power 2, 2 power 3, 4, 5, 6, 7, 8, 9, 10 up to k. ओके, तो हर बार हम पावर में 2 डाल दे रहे हैं और ये वैल्यू जो ना देखो एक एक इंक्रीमेंट हो रही है, 3, 4, 5, 6, एक से स्टार्ट हुई और के तक जा रही है, तो ये के टाइम ये लूप एग्जीक्यूट होने वाली है। तो ये के हमें बता रहा है कितने टाइम ये लूप एग्जीक्यूट होगी। तो इसको अगर हम सोल्व कर लें, यहां से हम के की वैल्यू निकाल लें, तो हमें पता लग जाएगा कितने टाइम ये लूप एग्जीक्यूट हो रही है। ओके, सो हाउ वी विल solve this? Take log both sides same. Log of 2 power k is equal to n. Oh, sorry, is equal to log n. Taking log both side. Taking log both side. I take log this side and this side also. So log n. Again, digit you can write base 2 here. Okay, we will be needing base 2. Okay, so we know this thing now. We are using this formula. Log of let's suppose a power b is equal b into log a. So this is the property of the log. Okay, so this is in power, I'm taking it to the front, so 2 power k into log base 2 this thing. Okay, so this is same log n base 2. Okay, and what is this value? This is 1, this is 1. Okay, what we left here? 2 power k. What we have here? Log n. Again take log both side, so I'm taking log both side. This is already finished. This is 1. Okay, so this is 2 power k equal to log n. This k will come in the front again using the same property, k into log base 2 equal to, taking log both side, I take log this side and this side also I need to take log of log n. Okay, so this value is 1 now again. So what is the k value? K value is log of log n, means ये वाली जो लूप है हमारी, this loop is executing k times. K value is log of log n. So this loop is taking how much time to execute? Order of log n. Log of log n. I hope this is clear now. This is the mathematical proof of this, how this is coming log of log n. Don't worry, ये सभी फंक्शंस को हम एक बार और रिवाइज करेंगे लास्ट टाइम समरी टेबल में. बिफोर दैट, वन लास्ट क्वेश्चन फ्रॉम माय साइड. कैन यू टेल मी how many times this loop will execute? Okay, let me execute this myself. This is taking order of n time, and this loop you can see actually this is starting from 1 and going up to I. This is starting from 1 going up to I, and this loop is executing 133 time. Okay, so can you people tell me, okay, can you people tell me, anyone, can you tell me what is the time complexity here actually? This is one gate question itself. So if you know this thing, you can write in the chat. Otherwise, I'm giving this question for your assignment, for your homework, and you can write the answer, what is the time complexity of this code, in the comment box. And I will also share the answer in the comment box. Okay, I will also share the answer in the comment box later on. So first you people try it, and you can share this. Okay, okay, so let's recap what we have covered till now. So let's recap. So if we have a loop like this which is going 1 to n, every time I'm incrementing with n, so this loop will take n steps to execute. So time complexity is order of n. If I'm starting from n and reaching up to 1, decrementing one step at a time, सबसे टॉप पे खड़ा हूं, सबसे नीचे आना है, एक एक स्टेप लेके आ रहे हैं तो n स्टेप लगेंगे नीचे आने में। सबसे नीचे खड़े हैं, टॉप पर जाना है, दो दो स्टेप एक साथ ले रहा हूं, दो दो स्टेप एक साथ ले रहा हूं, n/2 स्टेप्स में पहुंच जाएंगे। n/2 स्टिल अगेन ऑर्डर ऑफ n। सबसे ऊपर खड़े हैं स्टेयर पे, सबसे नीचे आना है, दो दो स्टेप एक साथ ले रहे हैं तो कितने स्टेप में नीचे आ जाएंगे? n/2 स्टेप्स में आ जाएंगे, बट स्टिल दैट इज एसिम्प्टोटिकली n। नीचे खड़े हैं, सबसे सबसे ऊपर जाना है, 10 स्टेप्स एक साथ ले रहे हैं, 10 स्टेप्स एक साथ ले रहे हैं, कितने स्टेप्स में ऊपर पहुंच जाएंगे? n/10 स्टेप्स में ऊपर। इतने स्टेप लगेंगे सिर्फ मेरे को ऊपर पहुंचने में, पर अगेन 10 इज कांस्टेंट, सो अगेन ऑर्डर ऑफ n कॉम्प्लेक्सिटी। सबसे ऊपर खड़े हैं स्टेयर्स पे, नीचे आना है 1 पे, 10 स्टेप एक साथ जंप करके आ रहे हैं स्पाइडरमैन की तरह, तो कितने स्टेप में नीचे आ जाएंगे? n/10 स्टेप्स में नीचे आ जाएंगे। n/10 इज अगेन ऑर्डर ऑफ n। यहां पे लूप के अंदर लूप है, आउटर लूप कितना टाइम ले रही है हमें पता है, n टाइम ले रही है। इनर लूप भी देखो n टाइम ही ले रही है, तो कितना टाइम लगेगा टोटल? टोटल कितना टाइम लेगी दोनों लूप मिला के? n इंटू एन, दैट इज n स्क्वेयर। ओके, आउटर लूप कितना टाइम ले रही है? n टाइम ले रही है। इनर लूप कितना टाइम ले रही है आप लोगों को पता है, every time you are multiplying with 2, you are multiplying here j value every time with 2, you are standing at 1, you want to go to n, every time doubling. If you are doubling every time, the complexity is log n base 2, and because this loop is inside this loop, so you will multiply both of them, so n into log n is the time complexity. What is the time complexity here? This is one loop only, this is taking log n time, this is taking log n base 2। okay, यहां सबसे टॉप पे खड़े हो, सबसे नीचे आना है, एवरी टाइम हाफ हाफ कर दे रहे हो, यहां पे डबल डबल कर दे रहे थे, यहां हाफ हाफ कर दे रहे थे, यहां ऊपर से नीचे आ रहे हो, यहां ऊपर से नीचे आ रहे हो, यहां नीचे से ऊपर जा रहे थे, एक ही बात है। यहां पे भी log n टाइम लगेगा, यहां पे भी log n टाइम लगेगा, सेम। ओके, यहां पर ये आप लोग अभी अभी हम सॉल्व करके हटे हैं। अगर i की वैल्यू को हम एवरी टाइम उसको डबल एवरी टाइम हम i इंटू आई कर दे रहे हैं, i पावर 2 मतलब i इंटू आई कर दे रहे हैं। हर बार अगर हम i पावर 2 कर दे रहे हैं, i पावर 2 कर दे रहे हैं, तो आपको पता है कितना टाइम ले रहा है? log ऑफ log n, दिस टेकिंग log ऑफ log n। और अगर इसका रिवर्स क्या हो गया, इसका अगर आप टॉप पे खड़े हो, आपको नीचे आना है, आप टॉप पे खड़े हो, नीचे आना है, और log n टाइम में आना है, log ऑफ log n टाइम में आना है। कितने टाइम में आना है? log ऑफ log n, सेम यही वाले में। तो आपको क्या लेना पड़ेगा? रूट ऑफ आई। एवरी टाइम यू नीड टू टेक रूट ऑफ आई, रूट ऑफ आई, रूट ऑफ आई। ओके, रूट ऑफ आई। सो एवरी टाइम आपको n की वैल्यू को रूट कर दो, रूट करके नीचे आ रहे हो, तो अगर कहीं पे भी रूट नजर आ जाए तो आप लिख देना टाइम कॉम्प्लेक्सिटी log ऑफ log n। कहीं पे भी पावर में आई की वैल्यू हर बार 2 से पावर कर दे रहे हो, log ऑफ log n बेस 2। अगर मैं पावर में 3 कर दूं, या 2 की जगह मैं आई पावर 3 कर दूं, दैट विल बी log ऑफ अगेन log ऑफ log n बट बेस 3। अगर मैं 30 कर दूं पावर में, 30 बेस 30। ओके, और रूट में यहां पे अगर 2 है तो बेस में 2 बाय डिफॉल्ट 2 ही होता है हमारा। अगर यहां पे मैं 3 डाल दूं तो बेस में 3 आ जाएगा। तो कुछ भी यहां पे कोई डाउट हो तो पूछिए आप लोग। नो पिछले क्वेश्चन के लिए n क्यूब नहीं है आंसर, आप दोबारा ट्राई कर सकते हो। आई विल शेयर द आंसर बट फर्स्ट यू पीपल ट्राई द प्रीवियस क्वेश्चन। यहां पे कोई डाउट है तो आप मेरे को बताइए। सभी के सभी कॉम्प्लेक्सिटीज हम कवर कर चुके हैं, ऑर्डर ऑफ n से लेके n स्क्वेयर, n log n, log ऑफ log n, और इसी के इन्हीं के कॉम्बिनेशन से आगे सब कॉम्प्लेक्सिटी आपकी बनती है। ओके ओके, so let's move to now gate questions. We have covered all the concepts, all type of complexity functions we have covered. Now it's exam time. So here is the first question for you people. Please try it. This is ISRO 2008 question. These are the real level you need to achieve actually. So can you people tell me what will be the answer here? So these questions actually, I have taken some questions are output based questions and some questions are complexity based questions. They will ask the complexity, how much time that is taking. Some questions are they are asking, okay, what will that will print. So this is written in Java actually, this for loop. This is system.out.print. So what this is going to print, please try it. Please try it. We have already covered all type of complexity functions. So from there also we will take questions, and these are also somehow related to the how how many times this loop is executing. So that's why I pick these questions also. So from Tripathi we get B answer. Any other? Anyone else? If you are getting the information from this session, please like this session. That keeps us motivated, and we put more energy in other sessions, actually next sessions. Please like it. That definitely matters for us. That's why we are asking, and everyone asks. That's why. Please like the session. So the Ravish also said B. We had 2 votes from for B actually, and B is the right answer actually. So here what we are doing is k value 0 going up to 20, adding 2 in k, taking mod remainder of with 3, and if that is equal to 1, then we are printing the value. Okay, then we are printing k value. So k value can be starting from 0, and then we are incrementing with 2, that can be 2, then 4, incrementing with 2 every time. This is important thing, you can skip actually. So we are not incrementing with 1, we are incrementing with 2. So maximum possible k values can be 6, 8, 10, 12, 14, 16, 18. Okay, up to this, when that will be 20, we will come out of the loop. Okay, and if we are taking mod of this value, so if we will take mod of 4, then we will get 1. So we will print 4. And if we will take mod of 10, then we will, so 10 mod 3 is 1, yes. So we will print again k value, that is 10, and 16, yes. If we will take 16 mod 3, and we will here also we will get remainder 1. So this will print we will come inside this condition will be true, we will come inside and we will print k value. So these are 3 value we will print. One is 4, one is 10, and one is 16. So B is the right answer. 4, 10, and 16 we will print. Okay. Okay, so let's move to the B is the right answer, yes. This is GATE 2007 question. Please try it yourself. If you do not like the session, please like it first. What is the answer? Shivam and Tripathi, both of you, please try again. Keep trying. log n तो आ रहा है, ये तो क्लियर हो रहा है क्योंकि हम 2 से मल्टीप्लाई कर रहे हैं। अब log n में भी इसने थोड़ा सा, log n में भी अपने को 3 आंसर दे दिए हैं इसने, तो आपको मे बी आप कुछ वैल्यू पुट करके देख सकते हो n की। Maybe okay, you can put 64. Let's suppose if you put 64 n value, then how many times this loop will execute? How many comparisons you need to make? These comparisons. So first, let's suppose if n is 64, then initially j value will be 1 comparison, then j value will be 2, another comparison, then j value will be again multiply with 2, 4, one more comparison, j value will be double 8, still less than 64, one more comparison, j value will be 16, one more comparison, j value will be 32, one more comparison, j value will be 64, one more comparison, j value will be 128, still the comparison will be there, but we will come out of the loop, but the comparison still will be there. Okay, the total is 1 2 3 4 5 6 7 8. Okay, and if you will take log of 64, the log of 64, you know that base 2 is 6. Okay, and here total comparison is 1 2 3 4 5 6 7 8. So I can say 6 plus 2, that is 6 plus 2. Okay, now one thing is sure, this option is wrong, this option is wrong. So out of this and this, that can be a possibility. So either floor or ceiling. Okay, floor or ceiling value. Let's suppose now let's suppose we are taking 63 value. 63 if we are taking, then we will not compare this thing. Okay, if we are not comparing this thing, 7 comparisons we are making. Okay, so 7 comparisons, let me write here, log of 63, we need total number, how much we need? 7. Now 7. Okay, so 2, out of that we need 2 plus 5 actually, so 5 comparison we need to make from here. Okay, so for that actually, if you want to take 5 value from here, you need to take the floor value, you need to take the floor value. If you want to take 5 actually, 2 is already you are taking. Okay, but the difference is here, in either you take floor or ceiling. So here you need to take the floor value because you need 5 value to make it 7 actually, 7 comparison. So this should be floor, you need to take floor value. So the answer is here is D. I hope that is clear. So you can simply take one example and you can put like that also. Okay, let's move to the another question. So answer is D. Try this one. Everyone, please keep trying. So this is ISRO 2017 question. If you will try with your hands, then you will get the confidence actually. So I think options C and D are not visible to you people. Let me write. C option is 0, 1, 2, 3, 4. D option is error. And B option is 10, 10, 10, 10, 10, 5 times. A option I think is visible. Tripathi, try once again. Gate aspirant, you also try once again. Keep trying. If you are getting wrong answer, it's okay. That is not the problem. If you are not trying, that is the problem actually. Because if you are not trying, then you will not actually understand. You will not open the screw of the mind actually. So we are getting Mad Max is saying B, Ravish is also saying B, Divyanshu is saying B, many people are saying B. B is the right answer, yes. B is the right answer. So simply what we are doing here is, let's see. Simply I value is in the starting is 0 going up to 5 means I value is going 0, 1, 2, 3 up to 4 is less than 5. And here this I is actually is belong to outer scope. This is the local, this I is having a local scope inside this block only. Okay, so what we are printing, we are printing local scope. What we will print, not outer scope, this will print the inner scope I actually. This will print 10, this will print 10, 10, 10 and 10 only. Okay, so even you are incrementing the I value, but next time when you will come again, you will get I value as 10, then you will print again 10. So this loop is executing simple 5 times. So 5 times you will print this inner I value, that is 10. Simple. Okay. So this is actually this belongs to this belong to outer scope. This is inner scope. In different blocks you can declare. In different blocks you can declare. Yes. Okay, next question. Try this one. This is GATE 2018 question. So these are not questions from my side. These are GATE questions actually. So the level of these questions are, if you are solving question yourself, then you will feel confident. Again, I think options are not visible. So A option is 4, B option is 5, C option is 6, D option is 40. So this is actually 2 power 40. And what is that? Digit? I know it's almost 2 hours, but don't lose your mind, okay? Digit? What are you typing over here? Okay, good, good. Okay, let me explain it. So here j value is 0, some another variable we have 0. If you are trying, please keep trying, otherwise I'm explaining here. So this is the this is one loop, this is another loop. Okay, both are executing separately. Okay, this loop is ending here, this is incrementing j value. Okay, and this loop is starting from n and going up to 1, and you are every time you are dividing. Okay, every time you are dividing with 2. So one thing is sure, this loop will execute log n time. How many times this loop will execute? Log n time. Okay, and what is the n value? N value is 2 power 40. And what is the, okay, let's take the log of this now. Log of base 2 will be there because you are dividing with 2, and n value is this is our input, which is the n. So that is 2 power 40. So 40 will come in the front. So what you will get here from here, this will be 1, 40 into log 2 base 2. So this is 1 actually. So what you get from here is 40. So this is what you get from here is 40. So actually this loop will execute 40 times. This loop will execute log n time. For this input, this loop will execute 40 times, I will say 40 times, because log of 2 power 40 is 40. Okay, and this loop is executing 40 times. So j value is incrementing up to 40, starting from 0 going, that will increment 40. So from here what you will get 40, j value you will get 40. And what you are doing here now, j value is 40, that is they have not initialize it. So here j value is 40, and that will come up to 1. Again you are dividing with 2, again take the log of log, this will again, this will loop will take log n time to execute. So log of, what is the log of 40? Log of 40 is actually how many times this loop will execute. For 40 actually you can see here, for 40 initially the j value is 40, then j value will be actually divide with 40, that is 20, then 10, then 5, then 4, then 2. Okay, so even you can say here, so this will execute actually log of 40 is actually how much, that is 5, that is 5, 2 power 5 is actually 32. Okay, and after that actually that will come, that will cross the 40. If I will say 2 power 6, this will cross the 40, so that should not cross the 40. So this will execute 5 times, this loop will execute 5 times log of 40. Okay, and some value in the starting is 0, so that will be incrementing 5 times. 5 times this loop will execute, so you will get the answer 5 here. B is the right answer here, you will get the answer 5 here. Let me recap this again, so j value starting is 0, sum is 0, this loop is executing, we know that we are dividing with 2, so this loop will execute log n time, this loop will also execute log n time. Now what is important is, what is this n? For this loop, n is given here, so that is log of 2 power 40, which is actually 40 we get from here, and 40 times this loop executes, so j value will be incremented 40 times, that will be 40. So now this is 40, again you are taking log, so log of 40 you need to take, so 2 power, for 2 power 5 that will go up to 32, for 2 power 6 that will be 64, 64 is greater than 40, for that this loop will not execute, up to 40 this loop will execute, so 5 times this loop will execute, for 2 power 5 only, so 5 times this loop will execute, so sum will increment it 5 times, so the value at sum will be 5. 5 is the answer. Okay, okay, so let's move to the next question. Try this one, GATE 2015 question. Keep trying. So I can help you here. What is the value you will get here is in J you will get actually 2. And what is the value you will get in K? In K you will get minus K equal to K minus 2, 0, minus 2 I think you will get. Let me check. Okay, so you will get minus 1 here. You will get minus 1. You will get K value at minus 1 and J value as 2. You can check out this thing, and can you tell me what is the output? Mad Max, D is I don't know, D you give the option for previous question or this one, but this is not true for this. D is not the right answer. Try this one. Please try it. Please try this. So J value is 2 and K value is minus 1. K value will be minus 1. If you will solve this, you will get 2 here, and if you will solve K, then you will get minus 1. Actually, J is 2, and then you will decrement J, that will be 1, and then you will 0 minus 1 is minus 1. So I directly mention J and K value. Then can you tell me, okay, how many times the printf statement will execute? How many times printf statement will, number of times the printf statements is executed. So these are the printf statements here. Any one answer, if I get one answer, then I will start solving it at my end. If I get one answer, then I will start solving it. Should I start? If you want me to start, then C. Yes, Digit, you are right. C is the right answer. So let me try now. This loop is executing 4 times. 0, 1, 2, 3, 4. And initially, the switch value here, I value is 0 plus K. K is minus 1. So 0 minus 1. 0 minus 1 is minus 1. Minus 1 is not here. So minus 1 is not here. So I will print 1 time. I will go into the default and I will print. Okay. Now I printed 1 time. So now I value is 1. So I value is 1. So that will be 1 plus K value is minus 1. 1 minus 1 is 0. So because this is 0, so 0 is also not here. So I will go to the default. I will print 1, this statement, default statement I will print, and I will come out, and I will get, again we'll go to the loop. So now I value is 2. I value is 2. So 2 minus 1 is 1. So I get case 1. I will go to the case 1. Nothing is here to print, but I will print this, and this, these 3 statements, because there is no break statement. There is no break statement. There is no break statement actually. That's why I will print all these 3 statements. So I will print 3 printf statements here. Now I value is 3, so 3 minus 1 is 2. I will start from 2 and I will again print all the 3 statements. I value is 4, 4 minus 1 is 3. I will go to 3 and I will print these 2 statements now. So total is 5, 8, 9, 10. So C is the right answer. C is the right answer. I hope that is clear. Get aspirant 2023. Is that clear? Any doubt you can ask me. Simple, the logic was here that break was not here, so that was printing. That will keep printing until the all the cases and default will be covered. Okay, so next question is this one. Here this is root of n. This is a function actually. This is like this. I have written a function. Okay, if n is less than equal to 2, then we will return 1, else this code I'm writing in the form of just by using curly braces and all. Otherwise we will return a. I'm recursively calling this function now, but now in this function actually I'm passing root of n value. I'm taking root of n, then taking the ceiling of that, and I'm passing that value. So how many times this function will execute? Every time you are taking root of n, root of n, root of n, n value is starting from some bigger value and you are making it smaller, smaller, smaller until unless that will reach to the 2, and when that will be reached to the 2, you will return back. Okay. So how many times you will recursively call this function actually, that depend upon this, how you are decreasing the value of n, how many times this function will be recursively called. So that will decide what is the time complexity of this algorithm. So you know already, if you have root n, if you are making root of n, every time, see, recursively you will call this function, next time the value will be root of n here, again you will call it, the next time that will be root of n, again root of its root, again its root actually. Okay, so if you can write it like this, that will be n by 2 and this will be n power 2 power 2. Okay, and next time that will be n power 1 by 2 power 3, like that, and this will reach to 2 and you will return back. So you know actually this thing, whenever you take root of n, then what is the time complexity, you know this thing. When you take root of n, we already discussed this thing, we already have discussed this thing. When you take root of n, you are standing at the top of the stair, nth stair, you want to come to the first one, and every time you are making root of n, root of n. Okay, so let's suppose n value was 1000 in the initially. If you are taking root of 10, so let's suppose 10 is here, then, or maybe, okay, 2 is here, then you will get 33. Again you will take root of 10, so you will get near about 5, again like that. So C is the right answer. So this will take log of log n. I can tell you one important point here, okay, that is that will be beneficial for you people. Let me tell you how you get the complexity if you are taking root of n. See, initially the value is n, after the value is n by 2. Root of n is actually, what is that? N power 1 by 2. And again if you are taking root of this, so that means n by 2 key power 1 by 2. So this is actually equal to n by 4, or you can say n by 1 by 2 power 2. Okay, so this is the next value. So I start with n, then n power 1 by 2, then n power 1 by 2 power 2, and then n power 1 by 2 power 3, and then n power 1 by 2 power 4, and so on, n power 1 by 2 power k. I don't know what is k, but we will reach to up to 1. We will reach up to 1, and we will stop when n will when this will reach to 1. Okay, so this k is telling me, again this k is telling me how many times I'm executing the loop, or how many times recursively I'm calling the function, because I want to make this 1, then I will return. Okay, so simple. Now you will take log of both side, n power 1 by 2 k equal to 1. Take log both side. Log of n 1 power 2 power k equal to log of 1, you can take here. Okay, this will come in the front. So this is actually 1 power 2 power k. Okay, and log n. Okay, and this is 1. Okay, this is only 1 only constant. This is some constant, actually this is some constant. This can be 1 or 2, like in previous example that was 2. So this is some constant. If you will take log of here, then you're getting constant only. If you're taking log of any constant, you will get constant. So I'm getting constant here. Okay, so still this 2 power k will go here. That can go here. So log n equal to 2 power k. Now again take log both side. So this will be log of log n, and this side this will be log of 2 power k. Again k will come in the front. So, and let me write k into log base to 2. This will be 1. Okay, so what is the k value? K value is log of log n. So what I want to tell you is that whenever you are taking every time root every time taking, you are decreasing the value, every time you are decreasing the value. So in how many times you will reach to the 1 or some constant 1 or 2, log of log n time, in log of log n time. So Divanshu, you are asking what is the time complexity of this. See, here you are going up to n by 2. You are saying that sir I am going to the mid of the stair. n स्टेयर्स हैं हमारे पास, आप मिड तक जा रहे हो और एक एक स्टेप ले रहे हो. कितने स्टेप लिए आपने मिड तक पहुंचने में? n स्टेयर्स हैं, आप मिड तक जाना है, आपको एक एक स्टेप लेके जा रहे हो. n by 2 स्टेप्स, कितने आप स्टेप्स लोगे? n by 2 स्टेप्स तो लोगे आप. आपने n by 2 स्टेप्स तक ही जाना है और एक एक स्टेप ले रहे हो, n by 2 स्टेप्स लोगे. So this loop will to execute n by 2 times. n by 2 is order of n. n by 2 is order of n. Okay, so this is again your homework. Now this is also homework, you can note down. Please write the answers in the chat box. I will share it over there. This is another question you people can try. Okay, that's it for today's session. The important part of today's session, let's go back. You can go to these questions which I have not solved. This is the most important part. You will not get all these things at one place. All the complexities, different type of complexity that can occur, maximum, that is covered in this table, which is the most important part of this lecture. So after that, you need just practice. Actually, you need to practice. Okay, you know how many times this loop is executing, that loop is executing, and they can make little tricks. But the base is this. The base is covered, and after that you need to do practice. No doubt, you need to do practice, because they are playing with these things only. They are playing with these things. Thank you then. Thank you everyone. Actually, the time is over now. I need to end the session. This session, yes, this gate aspirant is asking, is this course will finish before Jan mid? Yes, this will finish in the first week of Jan only. First week of Jan. Okay. Okay. Thank you everyone. Thank you, Digit. Hope I will see you people again in my next session. Tomorrow I have a session of operating system. We will cover complete CPU scheduling. Every year questions come from CPU scheduling. Every year. You please check out. and we will cover CPU scheduling tomorrow in its entirety. Thank you for today. If you don't like the session, please like it. Then thank you everyone. I'm ending the session. Thank you.